Hey everyone, welcome to your Ultimate Mobile Programming Masterclass. I'm going to be your tutor today, guiding you through this explainer to decode Android architecture and help you absolutely ace that upcoming exam. Whether you're building your very first app or just trying to wrap your head around those tricky past paper questions, you're in exactly the right place.
Here's our syllabus for this explainer. We're looking at 4 key areas: architecture and ecosystem, building interfaces and components, life cycles and logic, and finally, an exam survival guide.
All right, let's jump right into part 1, architecture and ecosystem.
Think of an Android device like a 4-story building. Down in the basement, handling all the heavy lifting, things like memory management and device drivers, is the Linux kernel. That's your concrete foundation. Right above that, on the ground floor, you've got the Android runtime and native C++ libraries. That's your execution engine. Moving up, the application framework is kind of like your building's plumbing and electrical wiring. It provides all the essential APIs. And finally, sitting comfortably up in the penthouse, you have the applications layer. That's where your actual user apps, like WhatsApp or Chrome, live.
Now, zooming in on that engine room for a second, a concept examiners absolutely love to test is the Dalvik virtual machine, or its modern upgrade, ART. Basically, this is a highly specialized engine. It translates and runs your app's code efficiently so it works perfectly on a mobile device, making sure it doesn't just hog all the phone's memory while it runs. It's crucial stuff.
So what kind of apps are we actually building? Well, there's a really clear distinction you need to nail down. You've got native apps, which are built specifically for Android and talk directly to the phone's hardware. Then you have web apps, which just run inside a browser. And finally, hybrid apps. Think of hybrid apps, built with tools like Ionic, as kind of a middle ground, trying to give you the absolute best of both worlds.
To actually build those native apps, developers use the Android SDK. It's basically a massive developer toolkit. And the absolute star of that toolkit is the emulator. You can think of the emulator like a flight simulator, but for your code. It lets you safely boot up a virtual phone right on your computer screen so you can test things out and squash bugs without ever needing to plug in a physical device.
Okay, moving right along to Section 2, building interfaces and components.
A super common point of confusion for students is the difference between views and view groups, but it's actually pretty simple. A view is just a single thing you interact with, right? Like a button or a text box. A view group, on the other hand, is the invisible box that organizes those buttons together. Oh, and keep in mind, all the visuals for these, like your colors and images, are tucked neatly away in your project's resource folders.
Let's look at a classic XML layout example straight from past papers. Notice how the view group here, which is a linear layout, acts as a container. And because we set the orientation to vertical, it perfectly stacks that first name text box directly on top of the submit button. It's simple, structural, and honestly really clean. Beyond what you literally see on the screen, every single Android app is built using 4 major components. You've got your activities, those are the physical screens you look at. Then you have services, which run invisibly in the background, like when an app plays music. You've also got broadcast receivers listening for system-wide alerts like, hey, battery is low. And finally, content providers, which handle sharing data, like your contacts. Knowing the difference between these is guaranteed exam material for sure. But how do all those components actually talk to each other? Through intents. Think of intents as envelopes delivering messages. An explicit intent has a very specific address written on it, like, hey, go exactly to screen 2. An implicit intent, though, is more like an open request. It's like shouting to the whole system, hey, I need to open a web link. Who can help me out?
Now, as your apps get more complex, you're gonna start using fragments. Think of fragments as mini reusable building blocks for your UI. Instead of rebuilding a custom navigation menu for every single screen of your app, you just build one fragment and plug it into whatever activity needs it. It saves you a ton of time and memory.
All right, let's switch gears a bit. Section 3, life cycles and logic.
Whenever you open an app, it goes through a very specific journey. You absolutely have to memorize this activity lifecycle. It goes in exact order, from onCreate when the app is first born, to onResume when you can actually tap the screen, all the way down to onDestroy when the app is fully closed and wiped from memory. So how does that change if we're dealing with a service instead of an activity? Well, if you contrast the two, you'll see that services completely skip visual steps like onResume or onPause. And why is that? Because services are literally designed to run entirely in the background. They don't need user interaction, so they don't need those visual states. To keep all this code from turning into a chaotic mess, developers use the MVC, or Model View Controller pattern. Just picture a restaurant. The kitchen is your model, right? It holds all the data and ingredients. The beautiful plate of food placed in front of you is the view. And the waiter? That's the controller. They take your order and seamlessly connect the kitchen to the customer.
When it comes to Java event handling, the absolute most crucial thing is using listeners to make your app interactive. In recent exams, you'll see snippets just like this one, showing an event listener patiently waiting in the background for a button tap. Once it hears that click, the onClick method kicks in, and that is where the magic and the math actually happens.
Let's bring it all home with our final section, the Exam Survival Guide.
First up, we have to talk about the Android manifest file. Listen, think of the Android manifest.xml as the VIP guest list at a super exclusive club. If your activity, your background service, or your permission request to use the camera isn't explicitly written on this list, the Android system's bouncers simply won't let it run. It's literally the most important configuration file in your entire project.
And what happens when your app is finally done? If your exam asks about deployment, this is the exact step-by-step workflow for getting an app securely onto the Google Play Store. It goes sequentially, from creating your developer account to generating a secure signed APK file, preparing your assets, all the way to hitting that final publish button.
Okay, let's look at the kind of logic they love to test in the code writing sections. Taking this classic if-else grading logic from a recent past paper, you'll often have to write Java code that grabs a user's input, runs it through these exact less than or equal to conditions, and spits out a letter grade. Take a mental snapshot of how these thresholds are structured.
Similarly, the salary deduction problem is highly tested. You have to know exactly how to declare your variables, calculate percentage taxes like a 15% payee deduction, and then subtract all those deductions from the gross pay to find the net salary. If you can confidently write out this math logic in Java, you are guaranteed easy marks. Free points, really.
Before we wrap this up, let's rapid fire through the most common mistakes examiners catch literally every single year. Ready? Always double-check your XML closing tags. Know the difference between explicit and implicit intents cold. Never, ever forget your Java semicolons at the end of a line. And please, lock in that exact activity lifecycle order we talked about earlier.
You now have the fundamental framework to build incredible Android apps and absolutely crush your exams. But as you sit down to write your code, remember this: the tiniest details dictate whether an app gracefully soars or completely crashes. So, will a single missing semicolon hold you back? Keep practicing, double-check your logic, and I'll see you in the next explainer.